Welcome to myprojectwizard.com. Our project title is Oruta Privacy Preserving Public Auditing for Shared Data in the Cloud. The main contribution of the project is the cloud aims to cut costs and help the users focus on their core business instead of being impeded by IT obstacles. Cloud computing relies on sharing of resources to achieve concurrence and economics of scale similar to utility over the network. To propose a novel isolation conserving mechanism, it supports the public analyzing on shared data based on their information which are gathered on the cloud. In particular, ring signatures are used for verification of metadata to audit the correctness of shared data. The integrity of the signer on each section in shared data is kept private. Shared information integrity without recover the entire data. With cloud data services, it is commonplace for data to be not only stored in the cloud but also shared across multiple users. Unfortunately, the integrity of cloud data is subjected to skepticism due to the existence of the hardware or software failures and human errors. Public auditing on the integrity of shared data with these existing mechanisms will inevitably reveal confidential information identity privacy to public verifier. We propose a novel privacy preserving mechanism that supports public auditing on shared data stored in the cloud. The integrity of the signer on each block in shared data is kept private from public verifiers. The main contribution of this project is to increase the privacy level of the data owner and the familiarity of the data in a superior way through the numerous cloud environment. Applying ring signatures to compose homomorphic authenticators in Oruta, which is this public verifier, is able to justify the probability of shared data without retrieving the whole information. And the user in the group can develop valid evidence metadata on shared data. In identity privacy, a public verifier cannot analyze the integrity of the signatory on each block in shared data all along the progress of examines. Now the flow of the project. Initially, the owners would choose the file for their user-defined. The user-defined files are generated as a specified key, and keys are encrypted, and the file are encrypted on the basis of key generation, and that encrypted file are uploaded in the cloud. In that cloud, the cloud verifies that means that the third party verifies the stored data as a attacked one or not. Then the cloud data are verified and the retrieval are based on the user definitions. The requests are forward to the cloud, and that for requested files are decrypted from the cloud and then repeated to the users. The users receive the requested file. Now the demo of the process. Initially, right click on the Oruta 1.java, then select run file. Click on image. We can show the user authentication, which is for authenticate the user who is responsible or not, who is authorized or not, included in the cloud. Give username, then password, then user defined ID, then the key are generated based on the user details. Then click authentication. The details are authenticated and stored successfully in the database. Database means which is stored in the cloud. Then click authorization. We should log in users and the authentication purpose. If the user and password are same, then the users are allowed as a valid user. Click authorization. The corresponding user's authentication verified successfully, then we can enter into the cloud services. Give port number, then connect to the client, then Oruta 5.java can be run. In this we give the same port number as we connected to the server. The client connection servers are successfully built. Then we can accept the client. The client requested are accepted by the server. Then click choose file, the user defined file. Load the file, then load files are encrypted. Then we can get the encrypted file size. Then file sensor selecting file. The selecting files are encrypted and that files are forwarded to the third party. The encrypted files, based on the encrypted file, the encrypted key can be generated. Then the files are decrypted to the receiving file. We get the encrypted file, then get the decrypted file and their corresponding size. Click key generation. The decrypted key generation and the encrypted key generation, the both key generations are combining and then compared with each other. If any modifications, the key will display as a modified one. Then click file audit, get the encrypted file path and decrypted file path. If any modifications on the decrypted, we shows the modification as a 1 boolean value. Then in this auditing phase, we can audit the existing and proposed. That means the encrypted and decrypted file concepts are evaluated successfully or not. If the encrypted file path and the decrypted file that each of the path can generate the key in the previous process, that keys are compared, then the compared values are same, the auditor approve the further process for the evaluations on that process. Then click evaluation. We compare the evaluation between the existing and proposed comparison. We can large size of data, we can get the large size of data and we can achieve the time complexity and over the computational cost compared with existing and proposed. The performance evaluation can be evaluated on the basis of existing and proposed consistency. The existing considering the overall time complexity and the computational complex of overall the process. The proposed system enhances the time complexity and overcome the problem of computational cost whenever storing the information between the cloud and the user's request. The user's requests are based on the user's definitions which are maintained in the third party. The clouds are transmitted over the third parties. Then the user sends the request to the third party. Based on the user's request, third party verifies the user's request on the cloud storage. Thank you.